Most computer simulations of climate change are underestimating by at least 1 degree how warm the world will get this century, a new study suggests. It all comes down to clouds and how much heat they are trapping. According to the study published Thursday in the journal Science, computer model simulations say there is more ice and less liquid water in clouds than a decade of satellite observations show. We saw that all of the models started with far too much ice, said co-author Trude Sturelmo, a Yale atmospheric scientist. When we ran our own simulations, which were designed to better match what we found in satellite observations, we came up with more warming. Sturelmo's lab at Yale has spent several years studying climate feedback mechanisms associated with clouds. Little has been known about such mechanisms until fairly recently, she explained, which is why earlier models were not more precise. The overestimate of ice in mixed-phase clouds relative to the observations is something that many climate modelers are starting to realize, Tan said. The more water and less ice in clouds, the more heat is trapped and less the light is reflected, said the study. She said even though it's tens of degrees below freezing, the clouds still have lots of liquid water because they don't have enough particles that helps the water turn to ice crystals. Because as the climate changes, there will be more clouds with far more liquid, and global warming will be higher than previously thought, Sturelmo said. Equilibrium climate sensitivity is a measure used to estimate how Earth's surface temperature ultimately responds to changes in atmospheric carbon dioxide. Specifically, it reflects how much the Earth's average surface temperature would rise if CO2 doubled its pre-industrial level. In 2013, the Intergovernmental Panel on Climate Change estimated climate sensitivity to be within a range of 2 to 4.7 degrees Celsius. The Yale team's estimate is much higher, between 5 and 5.3 degrees Celsius. Such an increase could have dramatic implications for climate change worldwide, note the scientists. It goes to everything from sea level rise to more frequent and extreme droughts and floods, said Ivy Tan, a Yale graduate student and lead author of the study. How much warming is predicted for the next 80 or so years depends a lot on if society cuts back on carbon dioxide emissions. In the worst-case scenario, with no carbon reduction, the United Nations Intergovernmental Panel on Climate Change sees temperatures rising by about 6.7 degrees by the end of the century, and Sturelmo said the liquid cloud factor would add another degree or more on top of that. While the study is well-reasoned and sobering, there are uncertainties with the satellite observations that raise questions for Chris Bretherton at the University of Washington, who wasn't part of the study. He said if the Yale team is right and there is a bigger cloud feedback, why hasn't warming so far been even higher? That's a legitimate question, Sturelmo said, but computer simulations may also be underestimating the cooling effect of aerosols that mask the warming but are diminishing in the atmosphere. This is just the latest in a series of studies that have found that mainstream science may be too conservative in estimating the pace and effects of warming, including melting ice sheets in Antarctica. None of this is good news, Sturelmo said. You always hope that climate isn't as sensitive to carbon dioxide as we fear, same with the ice sheets, but we're calling it as we see it. Several studies have come out and show that we've been too conservative up until now. Uncertainties in mainstream climate science are more on the bad side than on the side of less harm, said climate and glacier scientist Richard Alley of Pennsylvania State University, who wasn't part of the study. Climate science thus is probably more open to criticism of being too conservative than being too alarmist.